Welcome to OPC UA for additive manufacturing. Today we have Mr. Martin Geringer from Siemens AG, Digital Industries, and we also have Mr. Rainer Gebhardt, who is from VDMA, Association for Additive Manufacturing. Please, Mr. Geringer and Mr. Gebhardt, could you please introduce yourself and continue with your presentation for today?
Yeah, thanks for the introduction. My name is Martin Geringer. As already mentioned, I act as a chairman for the joint working group working on a specification for OPC UA for the technology additive manufacturing. And I will share later in the session some insights on where we are in terms of the specification.
Thank you, Zane, for this introduction, and also Martin. I thank you very much for being here today, and everybody, welcome to this session about OPC UA for AM. I'm working here at VDMA for this topic of additive manufacturing. We started with several topics about industrial use of additive, and so OPC UA, as we will see today, is a really important point. Our agenda for today is the first part, this is my part, the introduction to additive manufacturing, some short insights, what I see with the participants here. Many of you are familiar with this topic, but perhaps we have an overview just to see again what's important. And then allow me to introduce our working group within VDMA, and then Martin will present the details about what we have done, why OPC UA, and what is the specification, the different topics we have. At the end, a short conclusion and outlook, and we are happy to continue with the discussion together with you, question and answer. Götz is also with us here as someone who has many experiences with the OPC UA. Yeah, so the first point, this short introduction, additive manufacturing, it's not only one technology. One very important point is which material, and you see here an overview about the different technology within metal materials. So we have different processes, different material types, and surely different capabilities of the processes which are used to print metal. And the process is always a part of a whole process chain. So very important post-processing. Today, the focus is really on this layer-by-layer production, additive manufacturing called. And you see here on the left side, powder bed fusion, very well known, where you add energy with laser or others. The direct energy deposition solutions, which are very often where you have material added on an existing part or something like this. So you apply powder by laser or kinetic energy, or even you have a wire and you have electric arc just to add the material on the surface and to build up a part. Even also with metal, existing solutions with material extrusion, FDM, very well known on the plastic, but sometimes substrate is filled with metal powder, and so you can build parts which are green parts just to be sintered afterwards. And then the other technologies, binder jetting, also with metal, means you print with an inkjet bonding material, and material jetting as a solution where you also use a substrate and you have metal powder in this substrate, which is added by jetting with inkjet, for example. So this is a little overview, and there are several solutions also which are a little bit mixed and variations of these standardized explanations. Yes, some examples. Where do you use the technology? There are many, and it's growing always, but I think just to have a short impression about it, for example, if you see the spare part for the Deutsche Bahn here at the left side, This is really produced with a suitable production technology, which means you need a bigger part. This is not with a small powder and laser solution, but in this case, you need higher volume, and you use the wire arc. In the middle, you see a real function integration solution for aerospace, where you have small channels inside the part, and the real advantage is that before there were 20 parts, and now we have only one part. All things are integrated, no mounting and all these things which are necessary normally. And surely, which is also well known, the medical parts, where it's possible to realize individualized and personalized parts. And these examples were all produced with different technologies. In the plastic production, it's similarly. They have different technologies. Also, the powder bed fusion. In this case, it's a little bit different because you melt and merge the particles. It's not as much energy as with the metal, but the same principle. And then the material extrusion, very well known with plastics, and different variation, like from Arburg, where you use not a filament, but you use granulate, and you add only droplets on the surface of your part to build up the geometry you use without any tool. And material jetting is very well known. It's an inkjet principle to build up, and often with the curing system, UV curing system. The wet polymerization, that's the UV system with the photopolymer curing by laser energy in the wavelength, or even with the direct light processing, means a continuous process where you build up droplets, or in this case, inside of a whole volume, where you build the part by adding this energy by UV light. Yeah. And the examples you see, plastic as a wide range, even perhaps you have at home, but this is not the point of industrial production. But eyewear, for example, a typical example for personalized, customized products. And this is very good possibility with this laser powder bed fusion to build the personalized eyewear, which is really added value for the business. And the example in the middle here, this coupling hub, a part with mechanical function. This is used, or AM is used, because only a small volume of these parts is necessary. The tool for production, an injection molding process, is expensive, so additive is a good solution. And at the right side, this solution for ship dashboards, which is normally designed in a flat panel. This is also adapted to the real needs of the customer. And this freedom of design with additive manufacturing is the reason to use it. Yeah, and at the moment, I'm now in touch with AM since 10 years, and we are doing it within VDMA. And what we see is, okay, it's growing the industry, but it's really a big difference between, you see, prototyping without molds. Yes, it's an improvement for research and development in the industry, very successful, and often the door opener to be in touch with the technology, but it's not serial production, no volume. Manufacturing tools, there you have really advantage, because performance and quality is much more possible with AM, using AM technology. But more and more we see, and we hope it will grow in the future, and we need automatization for this, is production of spare parts, digital warehouse. For example, Deutsche Bahn is using this, it's growing this business, and surely improvement of products and the performance by functional integration, for example, flow optimization, process technology. There are so many solutions and so many things which at the moment are not really used, but we hope and we are sure that this will be technology for the future. So the transparency, which is written here, of the added value by using AM is necessary for the success and the industrial use of the technology. That's why we present all the technology everywhere we can. Yeah, so just have a short look at our working group within VDMA. We started 10 years ago, as I mentioned. We have now more than 200 members in our group, really representing the whole process chain. We will see it at the next slide, but it's so important to understand that there are different technologies and the possibility to use different materials. You need the suppliers, you need the partners just to realize it. And so this network in a group with all these participants, very important for success. Our main topics are on the industrial use of additive manufacturing with our mechanical engineering companies within VDMA, but surely for our companies to use it in their production of machines and their design, to understand what's possible. So the working groups are focused on industrialization. One part of this group is OPC UA, or quality and standards. Looking sustainability, a very important point, the possibilities with additive to produce lightweight parts. That's very important. Surely we need training, we need education for young people to understand the possibilities and to think additive. New markets and new applications. The visibility and networking with the industry as supplier and user of the technology to have a growing awareness and acceptance of AM. So in the next slide, this is not to discuss the details, but it's only to show you a little bit, to give an overview. You have the members of our company members, the logos, and the top, the technology suppliers from material, inside parts of the machines, the additive manufacturing machines, the periphery of the machines, and surely the post-process, as I mentioned in the beginning. This is very important to adapt it to the needs of the industry. And so in the lower part here, you have, sure, on the left side, the research, but then consultants and service suppliers who use additive manufacturing like a print shop, and to get a part, you send your design and they print it for you. But often it's more than only printing. It's understanding the process, understanding where you use it, and to optimize the parts. And a big advantage in our group is on the right side here down, all the companies within VDMA, most of them, who are potential users of AM or users of AM by buying parts or producing themselves, really for an application with all the needs which they bring inside the discussion of the group. Yeah, and so this understanding of the process chain is important for the industrialization. We are working in one group together. Martin is also with us in this group, really with this target, with this aim to have a smart factory with AM, to have an intelligent production chain where you start really with the idea how to use AM, the concept, and then to optimize the pre-process, which means design, for the best way to produce, because sometimes you have support structures or you have several steps in the post-process with the part. Even you have to optimize the real additive manufacturing process to have the best quality and result of the production. Then the post-process, there we need automatization. Often it's the same work time as the entire AM process. And then the understanding of the applications and the potential how to use AM. So this is our message, and this would we transfer to our companies understand AM and to use it in the right way and to use it in an industrialized way. This means quality and volume. Yeah, so I would like to hand over to Martin, because now we are in this next part of the presentation, why OPC UA. I hope it was possible to give you a short insight of technology and how we work together.
Thanks, Rainer. Yes, so after the introduction and some examples in the VDMA working group for additive, we want to look deeper into the topic, on the main topic for today's session, OPC UA for additive manufacturing. And here the starting point is why that is a topic or becomes a topic. As shown, additive manufacturing technologies are more and more applied also for really printing end parts, which are part of products in the end. And this means it becomes a real production technology, which with the requirements, with all the same requirements with conventional production technologies have to fulfill. So also integrating machines on a shop floor, on a brownfield or on a new greenfield is something that has to be supported. So this is the point 2. So data integration must be easy as possible. And currently, and that's the current status, the additive manufacturing machine-to-machine communication or also the connectivity to MES or cloud systems is driven by a proprietary communication. So each vendor brings his own, let's say, communication method. Some of them are using already OPC for communication. They have their own server model. They have their own information model. So it means in the end, they use the method of OPC UA for connecting, for sharing data or for exchanging data, but everybody uses his own information model. And this makes it difficult to, let's say, for an end user or an integrator who builds up a line, has different machines from different vendors. For each and every OPC UA information model, he has to do some own work for integration. And this, so far quite heterogeneous communication landscape increases the integration efforts, as mentioned already. And this is not the main topic. There are other ones in terms of productivity and maybe also repeatability, but also this thing that we have this heterogeneous communication landscape prevents additive from being more scaled up. So it means a need for standardization is also giving to easier integrate the technology into an industrial shop floor. Where did we, or how did we start, and where did we locate OPC UA? I mean, here you see the overall context where it is placed, where it's embedded. We started, of course, in the standardized approach based on OPC UA for machinery. And as several machines, additive manufacturing machines are also, let's say, have like a machine tool kinematic, are operating in a quite similar manner. We said it makes sense to use also the machine tool specification, where Götz is the chairman for this topic. He's also part of the meeting and supported us a lot for working on the first version of an OPC UA companion spec also for additive manufacturing. So this means we embedded the activities in the existing landscape of OPC UA for machinery, utilizing also machine tools, and based upon that we build up our additive manufacturing specification. And there we go into some further details. So we do not have a release candidate. We do not have a released specification yet. We worked on a first release candidate, and I give you some further details on where we are and what comes next later within this presentation. But first of all, we looked into what are generic use cases we want to support. I mean, you can support a lot of specific use cases which vary from technology to technology. So this means in the phase we concentrated on quite generic topics which are relevant more or less for all technologies shown. Due to this variety of technology, it's not so easy really to select generic ones. So the machine identification, that we say machine what are the properties, what are the capabilities, and so on, to see what materials can be performed, so that you can easily get information from the machine on the shop floor. What kind of machine is it, and what is it capable of? The next thing is like monitor machine condition, sensors, indicators, production operability. And one big topic is also materials and consumables. Typically, you have a different feedstocks. You have one for really for the part, the other one maybe for supports. This means it's what material is on the machine, what consumable is on the machine, the consumption tracking, and so on. And also the related availability. Is there enough material in the machine? Is there enough consumable there? And besides that, we also make use of machinery use cases, use cases described in the OPC or defined in the OPC UA for machinery, like find the machine identification, machine monitoring, and so on. Besides that, also we make use of the machine tool spec, and like the machine tool, the additive manufacturing type is somehow built upon the machine tool type. So, and one big topic which is currently, or which stopped us also from finalizing a first candidate for release, is the job management, which we also want to refer to based on the machine tool reference, that we also say we integrate the job management directly also or we make use of it in the additive manufacturing specification. But this job management was revised, and it was released in May this year. And based upon that, we will also revise again, and that's currently work in progress, also the specification for additive. So what happened so far, and so where we are at the moment, what comes next in terms of OPC UA. So this, I will not go through all the points. I think the main topic that Rainer mentioned already, it was triggered by discussions into the working group, where we say standardization on the data integration is a helpful thing for the further scaling of additive manufacturing, and also for the smart factory approach that Rainer mentioned. So this means we said this is a topic, and a group, or smaller group out of the overall working group came together, and we worked on the first, let's say, idea, what could be main use cases to address in the first specification. We started with the specification in 2021. We got an official working group in 2022. So you find here the link where you can find the working group details. And then we also make use of the OMATI platform, or OMATI Contact, which is promoting machine tool specification mainly. And we also work together with a machine tool colleague, like as I mentioned already. And in 2 years ago, no, not 1.5 years ago, at Formnext, which is a main fair for additive, in November, we made a first promotion out of it, and using OMATI as the marketing and starting platform. And in 2023, so already more than a year ago, we had the first release candidate ready, which I referred to. You see it here also as a screenshot, the cover sheet. It's available to download at the OPC UA website, but it was not released. It was stopped because of the release is pending, because we waited for the new machinery job management definition. This is now released, as I mentioned already. And then this started us resuming the activity with a strong support from Götz as our supporting us as an editor, since the original editor left the group. And he's also now working strongly on the feedback on the first release candidate, and also on the integration of the machinery job management, or machine tool job management, or machinery job management risk. So the idea is that we come to a new release candidate in Q3, and hopefully have a first release by end of this year. As I mentioned, out of the group of the additive manufacturing working group from VDMA, several companies, were engaged in order to build up a first specification. You find here the logos behind. It was not a continuous working group where every time all the members were with us. Sometimes maybe the one or the other stepped in as well, but I just mentioned here the main companies which also help promoting the standard in Formnext already. Good. So I would go a bit deeper in what is needed, what is, let's say, what you get, what you need in order to do the implementation. So this is not published yet. So you find all the node sets which describe the information model for a specific specification on GitHub. Here you find the link. And as let's say our OPC UA for additive manufacturing specification is part of the overall landscape and makes use of underlying, let's say, specifications already, you need a number of node sets already to start with. So if you have the first release candidate, which I base on my presentation today, the orange marked node sets are needed in order to start. In future, when we hopefully the first approved release candidate, the job management spec will be referenced as well, and for this, 2 additional node sets will be needed. So, and what do you need to do in order to do the technical implementation? If you are a machine builder, it's let's say your goal then in the end to provide an OPC UA server which makes use of the additive manufacturing information model, but of course you will also have your own nodes, your own variable, your own methods, and so on that you can add for your specific machine. So the goal of this OPC UA for AM specification is not to cover all information model aspects of the additive machine, but starting with a base that is the same for all machines. So first of all, you need, let's say, the node sets, which you can download from GitHub, as mentioned. You need a modeler. There are some mentioned. I will later use the Siemens, the freeware from Siemens called Xiome, just to show some practical steps of implementation. So the first thing is that you have all your necessary node sets. You load it into a modeler. You generate a new instance. You use the additive manufacturing name type to build up your machine. And then you can also modify that type in order to generate your own information model. After that, you can generate your OPC UA server. There are different there are different ways to do it, different software options. Like one is mentioned here, the Open 62501 standard. It's also possible to directly make use. For example, if you have a PLC controller, which is where OPC UA is offered by different vendors, that you can directly use the OPC UA server from the PLC in order to model or in order to implement, let's say, also the additive manufacturing information model. So with this, I would like to change to a very short live demo. I just want to give you some brief insight in how you work with. Many of you might know that already, but I think if you're new in the OPC UA space, maybe that helps you to understand how you need to move on. For this, I changed to the editor, which is, as I said, Xiome, which stands for the Siemens OPC UA modeling editor. And you see currently there's no namespace in. If you go here, there's just let's say the namespace. This is the UA namespace, the standard, which describes the standards or the very basics, the basics of OPC UA. And as first step, as I mentioned, you need to import all the namespaces. You can do it at once, but in order to show that it's quite a number. So the first one is a standard node set. You see that's the newest one. It changed from 1.4 to 1.5. Within the next one would be the DI node set, and I go it quite fast. The machinery node set, industrial automation node set. Then the machine tool node set, then there are some going around process data. These are these 2 ones. Then we go for the machine process values, and in the end, so these are all the preconditions. I mentioned that with the final, there will be also the job management node sets. I just show it to you, but The one that is now really showing is a result of the work we did in the working group so far. That is the OPC UA manufacturing node set. You see that is already quite old, and this was generated in combination or in parallel with the first release candidate. So it's from 2023, but it will not be the one that will be published, let's say, finally. But I start with this as well. So you have these different nodes, these different namespaces are included. And when you go on the left side, you see that the information model is there. And you see, for example, if you go for the object types, you see a base object type, and this includes all the different, let's say types that can be addressed, that can be used. And here you can select which information model brings what kind of information, what type with him. And if we go for the additive one, which is the last one, you see it's not a lot. There's something about consumables, so about materials and production runtime. And one main thing is the machine tool type includes a new subset or a new child, which is the additive manufacturing type. And this is the main type in the end now to build up your own machine instance. So the additive manufacturing machine type has some things, the consumables, materials, and tools, and so on. I will make use of that. So how to make use of that? So I got back here, you see all the object types which you need, which are the references you will use in your own object. I go to object machines, and with this I can start a new instance. New instance means I now make use of a type and adopt it to my own needs or select it here. With this I would start a new namespace, just call it my instances. Okay. And what type definition or maybe my AM machine as a name, and here I go for the object type. And with this, I would use the additive type directly. So this is, you see here, it's an own namespace and it's an own type, which comes from the namespace 8. And namespace 8, you cannot see here, was the one that we had as additive manufacturing. I start that and I get now a new machine here, which you can see it brings some properties already with them. And if I go, for example, to identification, you see there's the AM technology and identifier. Go to attributes. There's the manufacturer, there's the product instance, URI, and the serial number. But if I go for identification as a whole, you see there are much more properties there and much more variables there. So, example, the hardware verification would be a topic that comes from machinery and so on. You see here with the number, you see from which specific namespace this is inherited. So this means this from the machine tool type. This is also from the machine tool type. And you could use them as well. So you can use them and say, I add this because this would be what I would like to use. But for mandatory thing, and you see here, mandatory is not a lot. Mandatory is serial number, the product, and the manufacturer. And with the mandatory, you find the information in the specification, which, let's say, variables we see as mandatory to be filled, that everybody who using the additive manufacturing type has to fill. So this is just a short glance on the namespaces and also how to set up an instance. And I want to just add one more thing. I go to the namespaces again. I'm going to close that or lock that, and go back to the types. Look for again for the additive one. You find here the additive. You see here the additive manufacturing type. Go there again, and this is the type as it was, let's say, as you get it from the standard namespace. What you can now do is I make a new object type, and a new object type with a new namespace, and this would be I call it vendor AM namespace. So this is something where I now make use of the existing type. I generate my namespace, and this would be the vendor specific AM type. Good. So with this, you see, you have the vendor-specific AM type, which is under the additive manufacturing type. And here, for example, you can add a child and can say, now I add something specific, like my method. I add a method and say, okay, a node cloud will be a method, and add it here. And with this, I can say now, okay, I put in the input arguments and so on. I will not proceed here also because of time, but the idea is then when you now start again a new instance over there, you can then not use the AM, the additive manufacturing type, but your vendor specific. And this makes you capable that you say, I make use of the standard and add my own variables, you can add everything here in the vendor-specific AM type, which is based on the standard one, but add it with your own, let's say, own childs, which you can make use of. So that's just a short glimpse into what you can do, how you do it. And to be honest, I'm not the OPC modeling expert, so it's just some basics I would like to show within this presentation. I go back to the presentation. So, and just show you what, if you, in the end, you generate your own namespace, you export the namespace, and then you can use it to really implement your OPC UA server. So, but I don't want to only talk about the implementation and also talk why it makes sense. I think it's no doubt it makes sense to have a standard, but we also faced with some barriers for the adoption. I mean, we don't have a release standard specification yet, but nevertheless, we see that due to the variety, there's a large variety of different technologies, and it's not possible to really map the technological relevant parameters in detail in an overarching specification. For example, an end user using a laser powder bed fusion machine would be, for example, interested in the current laser power, right? Which makes sense because with this, maybe you can see what's happening there. But this is very specific for one technology, and in the other one, it would be a filament or whatever. So it means so far, in order to make it simple, we keep it very generic on the one hand side, which is a benefit for easy adoption in the first phase. But on the other side, of course, it's not fulfilling really the needs of all end users. But it's a matter of time, and we can, let's say, based on the selected AM technology, we could detail the information model even further. Nevertheless, my personal experience from my work in the additive industry in the recent years, and also what I see in the additive manufacturing working group of VDMA, so far the pull is not really strong. What I mean with pull is that machine end users, they're not really pushing the machine builders, so are not pulling from the machine builder that they want to have the standard. So this means in the end, the machine builder can offer what he wants. If he offers a good interface, the end user is satisfied. He doesn't really care about whether it's with OPC UA, or whether it includes the standardized information model. So this means this session should also create awareness that if such a standard should be applied and should be really become a standard that is adopted, it needs end users really asking for it, requiring it. So far, and that is one topic which is added here in brackets, in the additive industry, due to the high let's say, due to the process capabilities and let's say the time for introducing a technology into a new company, the effort is quite high. Typically, machine end users, they start with same machines or machines from the same machine builder. And with this, if you have 5 machines from the same machine builder, from the same vendor, I mean, you already have a standard because it's just one machine type standard you have to fulfill. So That is one thing which is still preventing the usage or the adoption a bit, but due to, I think the industry is moving into that direction, that more and more machine builder, more and more machine types from different vendors are also found on one shop floor, and this means this pull is expected to come. With this missing pull so far, a machine builder doesn't really see the reason to implement a standard which is not required. And so far, there's no competitive advantage with it. So it means if there's an end customer are longing for it, you are in a better position if you say, oh, no problem, I support it. It's already part of my OPC UA server setup, that the part of the standard I'm already using. The fourth thing, and this is something which one of the most important things when you connect to a machine, is that you send the job file to the machine, which is often generated offline in the engineering environment. And this is a data transaction which is which is done on a proprietary way in many cases. So with their own software from the vendor, and something own format, something protected, and this cannot easily be converted to OPC UA as a standard. So this means that will be a functionality that will be missed, but I don't see it on the midterm that this can be implemented into OPC UA. OPC UA, no doubt, it supports file service, but that is not, let's say, directly capable of supporting all the different formats, different ways that are done so far. And the last topic is that there are both pre and post processes which are implemented using other machine technologies like unpacking, like depowdering, like polishing, and so on. So far, we didn't look into that, but if you want to use OPC UA also to exchange data between process-specific information between different machine types, for example, let the unpacking machine get to know what is level of how to what level the build chamber is being filled. That would be something that we say we also have to think about what are exchange information with other processes. So nevertheless, I think that's not an argument. I'm not against the standard, but it's more an let's say to make you aware that if you are an end user interested in a standard, that you also have to request it from your suppliers. Why we continue, and this is what I mentioned a bit already. Of course, a standardized model makes sense. Also for relevant parameters like quality data, process performance, that helps that the new machine technology becomes successful. The additive manufacturing types contains the basic data. Still, machine builders can add their own part, as I mentioned it a bit already. The scope of standardization can and will grow over time. And overall, I think a generic information model is a base for serving current trends and issues that we say we have some aspects on sustainability, on tracking, on product data acquisition, and so on. So with this conclusion on OPC UA, I hand over to you, Rainer, again for the outlook.
Thank you, Martin. Yeah, thank you very much to see the example how to work with a solution and all these details. So just this last slide about how to continue, what's next, and Martin mentioned different aspects yet, but this finalization of the next version of the spec release candidate is important for us. So we take into account review comments and integration of revised job management. Yesterday we had a meeting, not finished, so we'll continue with it. If you are interested in, please let us know. This is in process. And publish and promote OPC UA for AM in the AM industry. As Martin mentioned, we need these industrial users, this industrial application, and for this, it has to be well known, and we need companies want to use the system. Implementation of the spec with the AM industry, based on the experience of the other OPC UA groups. I have to say thank you to the OPC UA group within VDMA. There are harmonization meetings, and we hear about activities of the different industries, but it is really an important point also because we have this process chain and we want to integrate AM in the whole shop floor in the production, and the production manufacturing machines around are necessary, and to optimize the system is very important. First application as part of an end customer project. Yeah, I think Martin explained it. We need these users. And yeah, the consideration of data relationships between AM machines and pre or post process operations, integration and harmonization with the entire process chain. I think this is also a possibility to make difference, to show that we know the whole process chain. We have possibility to have this good communication and integration, and to be successful in an industrial use of AM. This is really necessary. So I think this is our last slide for the presentation. We thank you very, very much for the attention